So I'm really looking forward to hearing what Darin's work is he's doing. So, round of applause, and thank you, sir.
Great, thank you.
Thank you. Round of applause. Yay.
All right, glad to be here. It's my first AES. Really excited about some of the things I learned. I'll tell you, I can't wait to get back to my own lab and put some AI avatars in some of our applications, so some really cool stuff around that. But my name is Darin Bolthouse. I manage a lab called the CHIL. CHIL stands for Collaborative Human Immersive Lab. It's a VR, AR, XR lab at Lockheed Martin Space. I've managed the lab since 2011, a little after it got started, so quite a while. It's been a dream job for me, and just gonna try to relate just some of the lessons learned over those many years in terms of XR adoption and some of the challenges and some of the factors that help you get this type of technology adopted. Certainly has changed over the last decade or so, and that change is not slowing down at all. It's just accelerating, if anything. So just super excited about what has already happened and what's to come. So in this talk, I just, really gonna not so much talk about the CHIL lab and the things we do. I'll touch a little bit on that, but really just kind of talk about some of the factors of adoption. There's a book I read back in college from Everett Rogers, the Diffusion of Innovation, and those factors of adoption have just kind of stuck with me throughout the years. Probably didn't mean a lot to me when I first read it, but as I've worked my career through different roles, really got to understand just how important these various factors are. And I'm going to do that in the context of the use case I support with the CHIL lab. Tons of great use cases throughout this conference, and with XR in general. You've got medical and architecture, retail, just tons of great use cases, but I'll kind of focus on the use case of design and assembly. Engineering, design, and assembly is kind of where we apply XR technology, at least in the lab that I manage. Start with a little bit of a story. So CoStar, I don't know if you can guess what that is or what that refers to, but it stands for Corrective Optics Space Telescope and Axial Replacement. And so I'm going to tell just a little bit of story. Jim Crocker, he's one of the, just countless unsung heroes of history. So Jim Crocker, back in the time that they were having trouble with the Hubble Space Telescope, he was an optical engineer working for NASA, working for Ball Aerospace, and he was the guy who came up with the design on how to do that optical fix. And not only did he come up with the engineering design to fix the optics, but he also came up with the idea on how to actually install it into the spacecraft. And the reason I bring that up is because Jim Crocker went on to be vice president at Lockheed Martin Space, and he was one of the champions of the CHIL lab and getting that started. And he always used to tell me, well, it'd be great if we had virtual reality, back then to help, figure out how to do that. NASA does have its own virtual reality lab now, and they do, they practice EVAs in virtual reality. You hear about the neutral buoyancy lab and training astronauts there, but they also train them in virtual reality. So I guess two morals of this story is, you need a really good use case for where you're going to apply XR, and you need a really good champion, like Jim Crocker, and he's going to make an appearance in a video. So I'm going to show you a video that gives an overview of the CHIL lab. It's a dated video. It's from 2013-14, so it's over 10 years old, but the reason for why we apply XR and sort of the business case for it is still relevant. You'll see like the Oculus DK1 in here too. So that was a big watershed moment of really advancing XR and being able to sort of get it more widely adopted, along with a number of other things. So let me show you this video, and then we'll get on with it.
The CHIL's absolutely amazing. This capability here is really used across the enterprise.
We can bring an engineer or a technician into the lab and we can put on a head-mounted display like the Oculus Rift. When they get in our motion capture system, they're literally sort of immersed in this virtual world, almost a holodeck per se.
You can do virtual walk-downs of the product. And when you can see it in 3D as opposed to seeing it on a drawing, you catch things much faster and much more effectively.
Scaled 1-to-1, so they're seeing the lifelike size of the geometry. They can look for access and clearance issues. And so it serves as a really great way to validate what we're going to do on the production floor before we actually do it.
And one of the things that's really exciting is there's really two technologies here in the CHIL. One is the cave, where you can actually stand inside, in front of, top, bottom, anywhere around a real sized object and manipulate that object in 3D space. You can look for interferences, you can look for all kind of problems with the vehicle. And then in the motion capture area, we can actually become an avatar, step into the factory floor, if you will, run the procedures and the processes, look for interferences, but as an avatar in a virtual world.
And there was a lot of collaboration that was going on between Space Systems Company and Aeronautics, who use it extensively through building the F-35 and F-22 aircraft. So a lot of collaboration, a lot of communication back and forth. And I think we brought the best set of capabilities and the best tools here in the CHIL. And today it's being used across all the enterprise Space Systems Company, making every program better and easier to build.
All of these things flowing through the digital tapestry across many industry sets are having profound impacts. And we at Lockheed Martin are on the very leading edge.
So this chart, I guess, I don't know, shows adoption or influence. So again, we built the lab in 2010. And honestly, when they were first talking about building it, I thought, oh, we're going to build this big, expensive lab with virtual reality headsets. And at that time, you paid, $25,000, $30,000 for a virtual reality headset. We had a full motion capture system. It was pretty complex. It, took a lot of time to get people set up in motion capture suits and things like that. And it's like, oh, should we be spending our money on this versus, maybe some more practical things, at the time. But one of the things, Jeff Smith was the gentleman who kind of started the lab. He's like, well, we need a place to sort of motivate and get people inspired to do this type of stuff. And so, that's what we did. We started the lab, but really, in it, and one of the factors of adoption, I think, that really helped is, okay, we had a place for people to come, educate them on the technology, show them the technology. And, so come, 2013, you kind of see the bottom of the pyramid there. We had, 3,000 visitors come through the lab. And, that hasn't tailed off. So even to today, we still give about 200 tours a year. These tours are to internal employees, to local colleges or universities or high schools, to our customers like the Air Force or the Navy. And so that ability to explain and show the technology to all those people have really helped drive adoption over the years. Some of the other numbers you see there of like active users and projects and participants, there was no exponential growth. It's just been sort of like slow and steady, keeping people informed and keeping up with the technology and the advancements. And so I guess that's one of the messages, there's no silver bullet. You got to kind of be relentless. You got to keep at it. You got to keep going. And then you just have to keep proving value along the way. And that kind of brings us to this chart here. So another great book called The Innovator's Dilemma by Clayton Christensen. He's got this concept in here of emerging technologies and existing technologies. And you're going to see this all over, right? Where you have emerging technologies take over the sustaining technology. But when you first start, you might be, incurring some costs. So that crossover point is, it's not fixed, right? It's use case dependent, it's technology dependent, it's dependent on when you adopt the technology. So you might take a strategy of, okay, I'm not gonna adopt this technology until I'm in the green space, but you might be falling behind your competitors, you might not be able to gain the competitive advantage of that, you might not get the value because you didn't start early enough. So trying to figure out, when to start the technology, when to put that technology in place is a little bit tricky and something to figure out. So, one of our big focuses for the lab is virtual ergonomics, using virtual reality for ergonomic studies and digital humans and assembly. And we've definitely moved that into the green, but I've made, other investments that probably didn't prove out. So it's kind of a running joke at our lab. I've spent a ton of money on, virtual gloves, haptic suits, and just, to date, none of that stuff has really proved out, but I'm just hoping for a day where that's a little bit more easier plug and play and works. So it's a challenge. It's a challenge to figure that out. You've got to invest in new technology. You've got to move the innovation curve ahead, but you've got to show value too, because if you're not showing value, you're not showing return on investment, you're not going to be around very long. The next, I'm just going to talk about these different factors. These are the different factors that are referred to in the book: relative advantage, compatibility, complexibility, trialability, and observability. Relative advantage, history is littered with technologies that were better than other things but didn't get adopted. And so certainly the thing that you're using, relative advantage, being better than the old thing is important. You need that. Otherwise, why are you using the new technology? But it's kind of it's not the only factor. So I think this one's kind of relatively obvious. It needs to be better than the last thing. But the key point here is this isn't the only factor. If it's just better, there's lots of other factors that could, sink your technology not getting adopted. Compatibility is huge, and it has lots of different facets and factors, right? So you have compatibility. There's a lot of talk about security. So, it has to be compatible with your security environment. It's got to be compatible with the culture of what people are used to and familiar with. It's got to be compatible with the work that people are currently doing. They've got to see how they get from point A to point B with your technology in the context of when and how you're applying it. So, this is really critical on so many different levels of how that gets applied. And so, the easier you can get that fit into the current system, the more widely that is going to be adopted. Complexity is huge too. We're really, from the moment we started the lab, there was lots of complexity to deal with. Again, I mentioned, when we first started, we were dealing with, this is, before the Oculus DK1, came out. There's a complex VR headsets. There's a complex setup to getting them going. We had a motion capture system. You could spend a half hour, getting somebody calibrated and set up. And so even in that environment, we had to figure out how to make it, easy for the folks that are coming in to use the technology, so they weren't just like, oh man, this just, isn't worth it, isn't worth doing. Had to work through lots of things with, CAD workflow, and how do I take my engineering CAD and get it into these different environments that we're going to use the data. So, complexity is something that's always on the top of, our minds. And, from my standpoint, if I can't show my, 80-year-old grandmother or my 10-year-old son how to do it, it's too complex. And so there's lots of, ways that, we try to reduce that complexity. And it's being able to deliver the content to the devices easier is one of those ways we do that. And so we're looking at a lot of times you have to hook up the VR headset to a very good computer, right? So we kind of use the HTC Vive as one of the main headsets we use at the lab, but you have to hook that up to a high-end computer. You have to put a high-end GPU in it, and that's a difficult setup for folks. So moving to things like standalone devices, like a HoloLens or a MetaQuest 3 or the HTC Vive Vision that they came out with, and a lot of this mixed reality, because a lot of that's where that's going. But because we have to put large data sets in, we have to figure out, well, how do we get those data to those different headsets? And then how do we, be able to deploy to all those different headsets? So, as one example, like HoloLight is a solution we're using for like remote streaming. And so that's a way where we can, stream to the headset. We can have the performance of rendering in the cloud and then streaming that data to the headset. And then we also have, security advantages too, where the stream is not persistent on that headset. So that's just kind of one example of a solution that makes it easier to deploy to the headset. It still maintains performance, and you get to put headsets in people's hands that they're familiar with. I think the Meta's sold like 20 million devices or so. So anyway, simplicity is no doubt very key. Trialability and observability, and I was thinking, why are these kind of broken out differently? Because they're different, right? So with trialability, you want to be able to give people the opportunity, to try your stuff out. So, with the CHIL lab, people can come in, they can try the headsets, they can try the different software platforms that we have that support AR or VR or mixed reality. But not everybody wants to put on a VR headset initially, right? So the ability to observe other people doing it and getting value out of it is another key thing. So again, the ability to have people, come to the lab, observe other people using the technology. It plays into, and as you're supporting different programs, part of observability is marketing what you're doing. So when you have success on program A or B, to be able to highlight those programs and show what's being done. So we have community of practices where we do like program highlights, we do newsletters, we have open house events. So I just, can't stress enough the ability to allow people to try software, observe it, and for that to drive adoption. So I kind of got through this a little quicker than I had thought, but hopefully you all have some questions. So I'm happy to answer any questions y'all might have.
So we have some questions. So I was just going to check and see if there was any on the app as well, but please take some from over there.
Sure, thanks. What would you say was your greatest challenge in getting acceptability and just getting XR into Lockheed Martin?
Like I mentioned, I had the fortunate of having a lot of executive support at the beginning. We had some use cases, not the Hubble obviously, but like initial use cases were some like critical repairs on some of our satellite systems, which kind of proved the value initially. So, from that standpoint, we're fortunate enough to have like executive support from the beginning from a top-down standpoint. But I think the, initial challenge is just, reducing the skepticism. Even though you had some champions, you had plenty of naysayers. And probably like all have you experienced, it's pretty unusual to get people that have sort of a level set understanding of like where the technology's at. You typically run into two types of people that are overly skeptical about the technology, or people that are overly enthusiastic about the technology. So I think it's about reining both of those different extremes in and just showing folks, hey, this is really where it can be applied. This is where it really adds value. And just executing on those initial pilot projects and things that you do. The key there is really you need to pick something that is going to work and you're going to have success in. And you know, that gives you the grace and leeway, you know, to do some more experimental things where you fail. So it's always going to be a balance of, you know, prove the value, but you gotta, you know, keep moving forward on researching new things. So.
I'm Corey Smith from Axiom Space. My question is, over the 10, 11 years you've run CHIL Lab, what is the best application that you've done for Lockheed Martin, most successful?
Probably the Orion crew module. So Orion is part of the Artemis program. So that, even though it looks a lot like the Apollo space capsule, you know, it's a completely, you know, new design with lots of new things and, you know, stuff that Lockheed hadn't built before. So, you know, Lockheed has been building satellites for a long time. So there was a lot of things that were kind of already known in terms of the assembly. But the Orion was a new vehicle design. So that was going through its initial design phases when the CHIL was first being stood up. So 2011 or so, it's going through what's called preliminary design review, critical design review. So that was a program where we got to apply what's called like a virtual build. So we would bring in, you know, the design engineers, the mechanical engineers, the technicians, and we would like literally virtually build that that vehicle up from start to finish. And we're kind of validating all the different assembly points along the way. So that was a really fruitful program because it was a new design. There were so many different interferences, ergonomic issues, design issues, and so I'd say that would be the most successful overall program. And in terms of use cases, you know, the repair use cases, because we build very expensive, complex stuff. So when a satellite goes through testing and something fails, a lot of times that thing, you just can't take the satellite apart the same way you put it together. So being able to figure out how to do that repair and get in there and to be able to dry run that in virtual reality, train technicians in virtual reality, use augmented reality to go show them how to do it. That would be another good use case, but maybe a little bit more unique to us. But.
Yeah, hello. Ron Thompson with CHIL. Great presentation. Question for you. What has been most gratifying about running the lab, and have there been any notable surprises over the years?
Well, the most gratifying is like being in the virtual reviews and like people finding stuff. It's like, oh, that's, you know, so that's like, you want to see the technology be successful for what it's, you know, needed for. Because again, you're going to get, you know, it's like, okay, I have a 3D model. I can go to my CAD station. I can look at it. You know, why do I need virtual reality? Why do I need to see it in full scale? But when the designer who's maybe been designing this part for the last 2 years gets in there and he's like, oh, I didn't realize it was that big or that small, or I wasn't gonna be able to reach that, or maybe that work platform isn't designed correctly. So just seeing the fruits of people being in there and discovering problems, that's no doubt the most you know, rewarding. And then, I don't know, what was the other part of that question? Most surprising or?
Surprises.
Main
Most
surprises.
what? Main, like surprises, things that you didn't expect to come up but did.
Yeah, I don't know what was the most surprising. I guess it was just kind of thing that pops to mind. You know, a lot of times when we were first trying to, you know, get people like exposed to virtual reality, you know, I guess maybe one of the most things I had the most fun with, like when we used to do this walk the plank exercise, and you know, you have that like Richie's plank experience nowadays, but you know, way before that, you know, when we bring people in, especially early on in the labs, you know, almost nobody had tried VR that we put in there. And so one of the first things we would do, we had this walk the plank experience where we raise them up on a plank and have them walk over this pit. And I loved all the different reactions that we had from people crawling on their hands and knees and screaming and falling sometimes. So, but anyways. All right. All right. Kurt has it.
Hey, for our company, we're I'm over here. We've had a lot of cases where we get stuck in the pilot phase. So even if we have a successful pilot, we don't end up deploying it at scale. What has helped you get over that hurdle, I guess, in your organization?
Yeah, I heard I was in another, I can't remember exactly who it was, but he said, hey, you need a roadmap for what's after the pilot. So, you need, if you're doing a pilot, just this end of that isn't the success of the pilot. So I think you need to lay out a roadmap where the pilot is just a milestone, to get to somewhere else. And I think that's the key thing is, one, get some executive support for that pilot, but get executive support for the follow-on. And when you show that you did what you said you were going to do, have that support lined up. It would be my best advice. Yeah.
Kurt from AWS. What are some of the value metrics you use as part of the CHIL lab to say this is gaining us value? Is it reduction in installation time, reduction in incidents? Like, what does that look like when you have to show your management that you're proving value as part of the lab? Yeah, so that's a never-ending question, right? And so one of the main things that we would do is, like, especially when we did these design reviews, and I mentioned Orion, maybe we find 50 different things that are of a concern, right? And so then you have to ask yourself, okay, I found this interference. Like, if I hadn't found this interference, like, what would have been the impact? What would have that cost me in a design change? Would that have cost me to lay on the shop floor? But then the other thing you don't know is, well, what's the probability that I wouldn't have found that another way? So you have to be able to rank that too. You say, okay, I would not have found this if I've done this with virtual reality, or, oh, I might have found it. So we kind of estimate the impact, but then we estimate, like, the probability that I may or may not have done this another way. And so in the end, it's kind of an estimate, but you've got to find some hard metrics, and you've got to be able to show people, hey, this was the result of doing it this way, and had I done it the other way, it most likely would not have been as successful. All right, well, thank you all for, it was great.
Amazing, thank you very much. Okay, so this is it. We're nearly finished. I'm just gonna, a last summary, or I've tried to summarize what I think we've learned today, and you can agree with me or not. So a few bullet points. So XR can solve a lot of problems, but you need to be really clear, concise, and understand the problem that needs to be solved. So you need to get focused. And I think that's come through for a lot of the talks today. Understand the potential deployment problems. So security, what I've taken away is buy donuts and make friends with your IT team, or give the donuts to your IT team. The safety managers, buy donuts and make friends with your safety managers as well. The ROI and the business benefit, measure before, measure during, and promote the hell out of your findings, okay? Change management. It's all about peoples and hearts. It's really important. Listen and work with them, okay? So the people actually using the technology. Managing the stakeholders. I'd love the part, if you were here to listen to Chris from Abbott this morning, leadership buy-in versus leadership passion. I think the leadership passion thing was something really insightful for me, so it was a magical insight for him. So my last kind of ask of you guys is help the ecosystem. Talk and promote your use cases and successes. It's really important. Think about and hopefully consider joining the area where you get a chance to learn from the experts, access to a bunch of content, research, promotion of your work, and help the ecosystem grow. At the end of the day, we've all got to help each other to continue to make this ecosystem grow even better. It's been an honor and privilege speaking to you today, and the funny old Brit guy will go back to England tomorrow. Please feel free to reach out with me with anything, and have a great rest of your evening. Thank you very much indeed.
you.